Howdy, and welcome to another one of our virtual tours of outer space. My name is Josh. I'm looking super washed out. There we go. And I'm part of the Morrison Planetarium team at the California Academy of Sciences, and I am delighted to be beaming out from my home to yours, another one of our tours of our solar system and beyond. So we're using a very special program for our presentation today called OpenSpace. And OpenSpace is really fun because it's planetarium software, the very same kind we use in our dome for some of our shows during the regular course of our normal interaction. But it's also something that runs on your home computer. Case in point, I'm running it on my home computer to take you on a tour. So if you are interested in planetarium software, astronomy, and open source stuff, go check it out. OpenSpaceProject.com is the place to download it. And you can basically do the exact same tour I'm about to by downloading it, playing with it on your own computer. So this week, we are starting off with a real heavy hitter in our own solar system, my personal favorite planet outside of Earth, and that is Jupiter. So we are checking out Jupiter, but it looks like Amazing Kid and Janet both have some cool suggestions of Neptune, Pluto, Saturn, and Mars. I think we got a whole show planned out amongst them. I wanted to start with Jupiter, not just because it is my personal favorite planet, but because it's doing something super cool in our sky right now. Now, normally when you point a telescope at Jupiter, you get to see a light, bright disk. That's kind of cool. When you point at a star, normally you just see a single point of light. When you look at Jupiter through a relatively large telescope, let's call it one with a 6-inch or an 8-inch diameter, then you get to see some details. Those details would normally be what are called the bands of Jupiter. The northern and southern bands specifically are dark stripes across the surface. If you've got a very powerful telescope, maybe something closer to the foot diameter, you might be able to pick out this red spot. Now, that's something super cool. I've seen it a couple times through a telescope here on planet Earth, but it shows up best in photographs of Jupiter, either taken from Earth or from spacecraft in orbit around it, like Juno. You can see another very charismatic feature of Jupiter, one of my personal favorites right here. If I told you to look for the face on Jupiter, it doesn't look like the face on Mars. I'll tell you that much. But can you see a weird monster smiley face on Jupiter? We call this Joopy McJove face or Jovy McJope face, but it's a very cute little 2 eyeballs and a mouth right there. Very strange feature to appear on the surface of Jupiter. So what is Jupiter doing in our sky right now that's so cool? Well, let me line it up just right, facing straight towards the sun from Jupiter, and I'm going to fly backwards. And as I do, I'm going to turn on what we call the orbit lines for our planets. That allows us to see where a planet is and where a planet's going. Well, if you look carefully, you'll notice there's another planet very close to Jupiter in our solar system. I'd say very close. It's still like, I don't know, 500 million miles away or something, but that's Saturn, back off in the distance here. So if we were to go and attach ourselves to our very own planet Earth, we would get to see something kind of cool. We would be able to see from Earth's perspective, and again, Earth is, let's see, right around here, okay? Those 2 planets are right next to each other in the sky. Very, very close. And guess what? Over the next month, we're actually going to see them get closer and closer and closer until they're almost effectively touching in the sky. Now, that's going to be really cool. It's not going to happen for several days yet, but if you stay tuned and you want to check out exactly what's happening and when, I will tell you to go check out our program that we usually do on Fridays, and our very own Bing Kwok will be able to tell you about what's going on there. So moving time forward just a bit, we should be able to see Jupiter catch up to Saturn, and from Earth's perspective, they will be practically on top of each other. And it's going to be right about here. So this brings up another cool thing you can do with OpenSpace, which really is control time too. An important part of planetarium softwares is not just seeing the universe as it is now, but as it was. You can plan out eclipses, like the lunar eclipse we had a couple days ago, or occultations like this, where objects in space seem to line up with each other. So that's a really cool thing to do. Saturn is also beautiful, and I believe was recommended by Amazing Kid. So let's go check that out. So zooming into Saturn, again, it's farther away than even Jupiter. Jupiter takes a long time to get to. This is going to be a bit longer than that. For a spacecraft hurtling through the solar system, I believe Cassini took about 7 years to get to Saturn. That is a long time. Looking at Saturn, we are seeing it from an interesting angle, one we don't normally see it from because we are boreal-centric. Now, that would mean northern-centric. We often show maps and the solar system with respect to solar north. This would be closer to solar south. So we're seeing the upside-down part of our solar system. But remember, there's no up in space. It's all humans making up bizarre coordinate systems to make ourselves feel more comfortable. But when you look at this, you can actually see the shadow of Saturn's rings falling on Saturn's south pole, giving us that kind of interesting, maybe like a wig or a toupee on Saturn. Looking from over here, you can see Saturn's north pole and its distinctive hexagon. Last week, we had some people asking about this. It hasn't been in the news much, but is an absolutely beautiful thing. You can see this kind of geometric shape on the north pole of Saturn. Really cool to see, and there are some great photos taken by Cassini during the course of its mission. Now, backing up from there, let's see. What's a good telescope to get to see Jupiter and Saturn? Oh, man. If you are interested in telescopes, especially around the holiday season, there are so many cool ones to check out. I could spend a whole half-hour show talking about my favorite telescopes because it is something I research every year, making a giant wish list for myself. But that's not the focus of this show. I will say, if you have interest in that, there's lots of telescope buyer guides out there, or email us at planet@calacademy.org, and we will do our best to recommend a telescope for you and your situation. Things to consider, though: size, how big is it? If you buy a giant telescope, you then have to store a giant telescope. You also have to carry a giant telescope. The quality of the mount is also very important. There are good telescopes out there. I think telescopes like my Dobsonian run a couple $100, but you can spend as much on a telescope as you want, and the sky is not a limit, it turns out, for telescopes. Okay, so before I get too sidetracked on Josh's favorite telescopes, let's see what else we had. Can we see those two giant planets with our naked eye? Yes, you absolutely can. All you have to do is go outside when the sun is setting, and in the direction of the setting sun, those two bright points, that's going to be Jupiter and Saturn. They are beautiful to check out, and it's going to be really fun to see them drift closer and closer together. So by the, I think it's by the solstice, around the 21st or 22nd, those two planets should be on top of each other in the sky. Promises to be super cool. Okay. We had other suggestions, though. I got distracted. We had Pluto. Pluto was one. Let's go check out Pluto. Okay, so heading out to Pluto, it looks like we just left all the planets of the solar system behind. We actually did. We left all the planets of the solar system behind because we are going to go check out something that is no longer considered a planet. It's considered a dwarf planet. Does that make Pluto any less awesome? Absolutely not. Pluto is still an amazing, super cool, and interesting part of our solar system. It's just not one that's defined as a planet, but that's okay. When we look around on Pluto, we can see a cratered surface, and that's very different than Jupiter. When we saw Jupiter, not a single crater to be seen. When we look at Pluto, we can see lots and lots of impact sites defined by this nice circular area. Sometimes they have that blip or blivet in the middle. That tells us it's a relatively big impact site. Now, looking around here, we can see more than just impact sites. We can also see these awesome mountains hanging out right on the edge of this bizarre, smooth, crater-free region that is a nitrogen basin, nitrogen-filled basin. Nitrogen is what we are breathing in right now, provided you are breathing air on planet Earth. Most of it is nitrogen. On Pluto, it is so chilly that we actually see nitrogen puddling on the surface. So this has about the consistency of toothpaste, I've heard experts say. That's really strange to think. Imagine air so cold, it's thick like toothpaste. Absolutely amazing. Okay, so quick stop by Pluto is never complete without a visit to Charon. So I'm going to take us there real quick. When we see Charon from Pluto and Pluto from Charon, we get to see an object tidally locked in the sky. Looks like my map of Charon is not cooperating today. Had a question from Lee. Why is Pluto not considered a planet? Has a lot to do with how Pluto goes around the sun. People think Pluto stopped being a planet because it flew out of the solar system or it exploded or something. Not the case. Turns out there's a group of astronomers that eats every so often, and when they meet, they go over their definitions. What should be considered one thing, what shouldn't be considered another. And the last time they met, the time before the last time they met, they decided Pluto shouldn't be considered a planet because it has a lot more in common with these small things in our solar system than the big major planets. There's a lot of things a lot more like Pluto than there are big things like Neptune or Earth. So if we categorized it with the things that are most common, have the most in common with it, I should say, then it looks like it's one of these dwarf objects. It's a big dwarf object, to be sure, but it's closer to them than to us. So in our solar system, we have a handful of dwarf planets. I think there's about 8 last time I checked. We have 8 major planets, we have 1 star, and we have countless small objects. And I will say, if you are a fan of the small stuff in our solar system, you are going to want to tune in this Friday because we have an expert in comets, asteroids, and meteorites joining us, telling us all about the work that she does. So tune in for Marina's broadcast this Friday if you are excited about learning more about these tiny things flying through our solar system. I, for one, am very excited to see what she's going to be telling us. We got a sneak preview when we were doing a check today. Man, does it look cool. So I believe our last initial request was for Mars. So I'm going to head that direction, but I'm eager to see if there are any more conversations popping out. Other things about Pluto while I'm on the way. It's a small object. It orbits its moon Charon as much as Charon orbits it. It has a very elliptical orbit. It has not cleared out its orbit, so there's a lot of other stuff that orbits at about the same distance as Pluto. But it basically does not fit all the criteria the International Astronomer Union put forward to say what is a planet versus what is not. What is definitely a planet, but is now actually, if you think about it, the second smallest planet in our solar system is Mars. I've not thought of Mars like that before, and I guess it's technically true. The only planet smaller than it is Mercury. Venus and Earth are both a size category up, to be sure, about the same size category. Then you get to Neptune, Uranus, Saturn and Jupiter in terms of our total size. So looking around on Mars, you'll notice a little bit more in common with Pluto, actually, than Jupiter. Why do I say that? Craters. We had a question pop up about why are there so many craters. Our solar system is brutal. We have things flying around all the time, smashing into stuff. We think we had more in the ancient past than we do today, but there's a lot of objects like asteroids that just move around and smash into things. And when they do, they leave dents like this behind. There are some great animations out there if you want to see what happens when something hits the surface of a rocky world. And it looks like the surface actually becomes sort of a liquid. It can flow like a liquid when there's enough energy, enough force being translated into it. In giant impacts that create the double ring structure, we can watch huge titanic forces moving around, reshaping the rocky surface. So I actually happen to notice a double-walled crater right here. At least I would bet this is a double wall. I suppose it's possible that this is an outer wall and this is a separate crater because it's sort of off-center. But when we look at that kind of shape, it is an interesting suggestion of that kind of double wall structure. A double wall happens when something really big hits. It's when you get that rock flowing. That's kind of like the impact that took out our friends, the dinosaurs. Are all craters impacts or also volcanoes? Actually, for a long time, astronomers were pretty sure whenever we saw a crater that it was a baby volcano just starting off. The little tiny volcanoes started and then grew over time to become big volcanoes. And when we saw a crater, it was just the beginning of a volcano. That was, I think, the 1700s or 1800s. But then people started studying dynamics a little bit more and how an impact would happen and the kinematics of something smashing into another. And they put forward that what we see as craters are actually caused by things falling and hitting the surface of a rocky world. Turns out, we think that today we hold to that same theory. So when we talk about something hitting the surface, that also meant that something had to fly through space and smash into you, like an asteroid or a comet. That was a little terrifying for astronomers in the 1700s who didn't yet understand the commonality of these things. So there was a little bit of like, wait, are you telling me that a rock falling from the sky is actually sort of a plausible thing? And the astronomers were forced to say, yeah, maybe. That sounds like maybe a possible thing that could happen. So we are looking at the moon right now where this initial discovery happened. There are volcanoes on the moon, but they are few and far between. Far more common are those impact sites. But when we talk about the likelihood of an impact on the moon, something that could disrupt a moon base, like Collins suggested, it seems like a pretty low likelihood. About what we have here on planet Earth, any moment of the day you could be walking down the street and a little chunk of rock could fly down and bonk you. But the likelihood of that happening is incredibly low. A human doesn't take up much space, and the likelihood of a rock bonking us is very, very small. We have a lot of requests for Mercury. Well, I'm going to fly us to Mercury, and you're going to say, Josh, why did you fly us to the moon again? Because Mercury and the moon actually have a lot in common. They look very similar to each other. They're about the same size, and they are most definitely the same color. That color is gray. One of my favorite facts about Mercury is that Mercury is famous for being the gray planet. It's got some slight variation in color if you magnify it by enough, but it's mostly just gray rocks, just like the moon, just like Mars, just like Earth, and just like Venus. You might be thinking, Josh, you just showed us Mars. It was definitely red-brown. Why the heck would you say it's gray? Well, the red-brown is the dust on the outside. If you look at the rocks, they're mostly gray. When you look at the rocks of Mercury, they are most definitely gray. You can see tons of variation in the gray. There's some lights, some darks, and everything in between. But looking around on Mercury, you see lots and lots of craters. Interestingly enough, very few volcanoes on Mercury. We think that the rocky crust of Mercury is much less dynamic than that of the moon. We don't see as much flowing lava on the surface. On the moon, it shows up as these broad, dark patches we call mare. If you think about the dark features that make the so-called man in the moon, the face in the moon, the woman in the moon, the fox in the moon, the rabbit in the moon, there's a lot of different ways to interpret those dark features, but Mercury doesn't have them. The darkest areas are this kind of more iron-rich rock. The lightest areas are ejecta, rock blasted out from impacts on the surface. But Mercury is still a very photogenic planet, one that's often overlooked, which to me is very sad. Can we go to the sun? Absolutely we can. Now, I don't think this sun is updated with it, but I would encourage all of you, Rena, James, anyone who is a heliophile, let's call it, to look up the recent sunspots, because man, have there been some cool sunspots. Oh my gosh, the sun's missing. I got to fix this. Okay, so if we go into scene, there we go. There's the sun. You never want your sun to vanish. That makes for a real rough day. Okay, so looking at the sun, if you look up recently, we've had some sunspots, and that is super exciting because we have had like no sunspots for years and years and years. I think the last time I remember seeing a big cluster of sunspots was like 10 years ago. So, but it's entirely possible I'm misremembering, or there was a big cluster and I just didn't notice. I don't spend all my time thinking about the sun, just a lot of it. But if you check it out, the sun has these sunspot clusters from time to time, and it's been an exciting, I think, week. Mary can maybe find a picture of them. But the sunspots that have shown up are big, maybe about the size of Earth. Now, when I say an Earth-sized sunspot, a lot of people would imagine that covering the face of the sun. It doesn't. It really doesn't. An Earth-sized sunspot only would be maybe, I don't know. Let's find a good. See this light spot right here? That whitish area? That's maybe a little small. But something about that size would be about the same size as planet Earth on the surface of the sun. So when we imagine the sun's size, the best way for me to do it is to imagine 100 Earths across its middle, 100 Earths from top to bottom, and 100 Earths from front to back. Now, if you do that math, that means the sun's about 1,000,000 times the volume of Earth. And sometimes people say that 1,000,000 Earths could fit inside the sun. And all those people, I say, you need to spend more time looking at a gumball machine, because little tiny round things don't fit inside a big round thing super well. So when you're looking at the sun, keep in mind that it is 1,000,000 times the volume of Earth, but I think someone did the math and it's like 900,000 Earths could fit inside it. Not quite that many. So some people say the sun is expanding. Is that true? What impact could that be? The sun was probably bigger in the past. So we think about the sun over time. When the sun was first born, it was probably a little brighter and a little bigger than it is today. It's decreased slightly over the past, I don't know, couple billion years to its current brightness. Now, it's possible that in the sun's far distant future, we're going to see it undergo similar predictable changes, and we are going to see it change from its current state, which is sun is a mass of incandescent gas, but it's not, it's actually plasma, changing into a red giant. And that change is something that'll happen very slowly, at least 1 billion years from today. But that will mean that the outer parts of the sun puff out, get farther away from it, and actually reach out to about the orbit of Earth. The sun's going to get to be about 200 times its current size. And I hate to tell you, when you get to about 200 times its current size, it's getting very close to the orbit of Earth. So what does that mean for Mercury and Venus? Nothing good, I'll tell you that much. But when you look at where Earth is, it also is going to mean that Earth will no longer be a spot that can really do much for life. That's not great for us. So, well, let's see. We should majorly make sure that human beings have settled someplace else. Bella checked in. This is the OpenSpace project's open source Planetarium software. Check it out, download it, play it. It's super cool. Okay. Now, let's see. Anything else we had pop up? How big is the OORT Cloud compared to the rest of the solar system? Now, we can actually show you the OORT Cloud on Friday. The other version of OpenSpace I have has the OORT Cloud built in. But let me get out to where we would be able to see it. Double check I don't have it loaded up. Aha! OORT Sphere. I do have it, just not loaded up. So, to see how big the OORT Cloud would be, it's about 2 light years going out from the sun in every single direction. Now, that's kind of amazing. Thinking about something 2 light years in diameter, in radius, 4 light years in diameter, this thing is ginormous. So any point in here, if you were to send a signal, like let's say we press a button and the sun turns plaid, it would take you 2 years for that signal to reach this red grid. The OORT Cloud is what I would define as the boundary between our solar system and interstellar space, because the OORT Cloud is where the longest period things, the slowest movers that still orbit the sun, hang out. So for things beyond this, they probably don't orbit the sun. For everything inside of this, it probably orbits the sun. The only exception I would say off the top of my head would be things like Oumuamua, where if you tuned into Oumuamua and the information surrounding it, it is an extrasolar object that swung through our solar system and then swung right back out. So it left our solar system and took off for parts unknown. Okay, let's see. We're getting pretty close to time, but I think we got time for at least one more suggestion. What are we thinking? Any ideas? Let me turn off our display stuff. Okay. We've got a lot of interesting people speculating about the eventual fate of our sun, but ooh, I like this idea. Let's go check Uranus. All right. So heading out to Uranus. This is actually heading into Uranus because we were so far away that everything is sort of in from this point. It's a different color, you might notice, than our orbit for Neptune. Neptune is this deep dark blue color. Uranus has this pale robin's egg blue. Now, why did we choose the pale robin's egg blue color for Uranus? This, to me, is one of the coolest colors in our solar system. It's because Uranus actually is that pale robin's egg blue. It's just beautiful. A great color to look at. One that I hope we get to paint a room in one day at my house, because, man, is that a cool color. But when you look at Uranus, you can see the whole surface is not uniform. There's light spots and there's dark spots. There's also kind of a yellowy region. Now, this is, I think, some of the best photography we have of Uranus. In OpenSpace, they always try and use the most current and up-to-date photos when available. These are they. However, this is photos mostly taken from Hubble and modified by images from our Voyager spacecraft that sailed past in like the 90s. So you remember what digital cameras were like in the 90s, right? Not good. Well, turns out a lot of our photos are not fantastic either. It reflects Uranus as it was. In order to study Uranus in greater depth, we'd really have to send another mission. Time to spend orbiting it, to really learn about its seasonal changes. I think this should be a mission we plan. In fact, it's a mission we already planned at one point, but we have since moved away from that and abandoned that project. But if we keep funding NASA, keep putting money in their pockets, eventually at some point, I'm sure we will get an outer planets explorer and a chance to go visit Uranus and Neptune and learn some more about these places. Oh, looks like we've got another suggestion for Titan. I think that's probably going to be our last stop, but I cannot resist an opportunity to go visit Titan. It is just about the coolest moon in the solar system. At least let's call it my favorite moon this week. Titan, when we get closer, has an iconic appearance. From Earth, it is bright, bright, bright because it has a thick atmosphere. Now, when we look at it, we're actually going to see not the atmosphere wrapped around it. We're going to see photographs of the surface. But these are very interesting photographs. It's going to look different than Mercury. It's going to look different than Mars. And that's because we have these stripedy bits on it. Now, that's where the individual photos were stitched together. Kind of makes it look a little strange, but these photos were taken through Titan's prodigious atmosphere. Now, that gives us a chance to understand the lakes on the surface, the sand dunes moving around, and the icy bedrock. How could we have icy bedrock? It's not bedrock mixed in with the ice. The ice actually acts as the bedrock on the surface. Can we see the lakes? We absolutely can. Now, the coolest thing about these lakes, I don't remember all the names. These are they, flowing around the surface of Titan. But they have super cool names like Kraken Mare and Legia Mare. They're named for sea monsters here on Earth. So every lake on the surface of Titan is named for a different mythological sea monster. Just an awesome naming convention. The only one I think that can keep up with it would maybe be Sharon, which has important sci-fi and scary monster names for its structures. So does the atmosphere affect stuff on Titan? There's definitely winds and stuff that happen from that atmosphere. That's actually a really cool question. If there's storm effects on Titan, maybe disruptive atmospheric patterns. I know it rains. I'd be willing to bet that there has to be some storm activity. But that's Josh doing an I reckon, not an actual fact. So I would want to double check that. I'm trying to think. This could be productive for a future cosmic conversation because we know some experts on Titan, and I bet they could answer this and some other questions. But if that happens, we will update our Facebook page and let you all know to tune in if and when we ever get a Titan expert to come help us out. But with that, I think we are very close to our time. I'm going to start heading home. And as I do, I will say to all of you my extreme appreciation for you joining us here. It is always a delight for me to get an opportunity to just poke around in fun software like this, to answer questions and to share my passion for space. Astronomy, to me, is the most wonderful subject you could ever ask for because you are studying everything that exists out beyond Earth's atmosphere. There are so many cool new stories, so many exciting details to uncover in our own solar system and beyond. I'm a big fan of what we call galactic morphology, the shape and activity of galaxies. And there was just a big, exciting headline about how we've discovered we had the wrong distance to our supermassive black hole in the center of our galaxy. It's probably closer to 25,000 light years distant, not 30, which seems like a small refinement to it. But you're going to see some news stories in the next week about how the black hole in the middle of our galaxy just got closer. I'm telling you not to fall for it. We refined our measurement. It's not like we're about to get sucked in. But with that, I would like to thank all of you for joining me here for our virtual tour of outer space. Download OpenSpace. Let us know what you think. And think of some more suggestions for next week, because it is always so much fun to hear what you are thinking about and to try and answer any questions you might have. From myself and from the Morrison Planetarium, we are not able to open our dome yet, but we're going to keep sending these programs out until we are able to. For our friends at OpenSpace and the American Museum of Natural History, we thank you for tuning in. Have a wonderful rest of your Wednesday. Bye.